I am Satvik. I am from CMR College and I am currently in my fourth year.
What all projects have you done, Satvik?
The main projects we have done here are the recipe project, and we have done UART, Sync FIFO, asynchronous FIFO. We have also finished UART with using FIFO and pipeline recipe. We have compared the regular recipe with pipeline recipe and UART without FIFO with UART with FIFO. And so for us to understand these main projects easier, they have actually taught us two mini projects which are GCD and booth multiplier. So initially sir told us GCD. GCD was told to us for one reason only. It is to differentiate between data path and control path. It is also taught us how control path will automate the signals we require for the data path. So from there we went to RISC-V. We have built everything from the scratch. It's not like they just gave us some random hardware and they told us about it. We started from the scratch, taking one type of instruction after the another. Initially, we took load word from the immediate instruction type and we have built for it. We have chosen load word initially because it is the critical path. That is, it will have the most amount of components and it will take the most amount of time among all the instructions. So we took that as a foundation. Next, we have upgraded it by using store word, which is a S-type instruction. Then we have upgraded it further by using add, which is a R-type instruction, and then branching, which is a branch of equal, which is a B-type instruction. So not only have we learned how to do RISC-V, we have also learned how to upgrade it. So in future, if we want, we can upgrade it with jump, which is a J-type instruction, and even other type of features. So we have also learned how the control path will automate it, and we have learned the data path in complete detail. We have actually built it from the scratch rather than just sir telling us. Sir told us to try and how to think to build the data path. So now we can even, like when we have just woke up during our sleep, or even if sir immediately asks us, we can immediately do everything, including the code itself. And then we have compiled the code, we have synthesized it, we have implemented it. And then we have done the timing constraints and power constraints, and we have marked its reports. And next, actually what we did is another mini project called as booth multiplier. This booth multiplier was for us to introduce pipelining concept. So this pipelining will make it so that it will be more immune to noise, and it will also make it the performance of it faster. So after we have learned pipelining, we have implemented this RISC-V using pipelining, and we have compared the results. And the next we have done UART without utilizing FIFO. It was our first communication protocol. It was a peripheral protocol. Sir told us in detail how everything works, why baud rate is required, why asynchronous, we will use asynchronous, because asynchronous will work with different clocks. And when it is working with different clocks, it will also work with same clock. So an asynchronous can be also used as synchronous. But there will obviously be many difficulties for it. And sir told us in detail what the difficulties will be, how to overcome them. And to overcome them, sir taught us FIFO. But synchronous FIFO is a complex project. So before that, he even taught us synchronous FIFO in detail. Afterwards, we have learned asynchronous FIFO. And then we implemented this asynchronous FIFO in the UART protocol. So we have done UART with FIFO and without FIFO, and we have seen what errors can be overcome by using this. And another things are, sir even brought an FPGA board, and we have seen the entire Vivado flow. We have done thoroughly with the Vivado tool, starting from initially selecting the board we require, then writing the design code, simulation code, and even the XDC file, which is for the FPGA board. And in the simulation code, rather than just some regular test bench, we have done a self-shipping test bench. And after that, we have synthesized the design, checking the power and timing constraints, then implemented it and doing the same power and timing constraints again. Afterwards, we have generated our bit stream and we are connected with the FPGA board, and we made the FPGA board work as our code. We have verified using the FPGA board, and we have seen how the entirety of Vivado works without missing any steps. And after this, sir even also started teaching us STA. STA is not very much required for the design engineers, but it is still much required because they may ask us about PD related jobs. And the most important topic in PD is STA. Sir has started and taught us almost everything, and he is even currently teaching us how to use PrimeTime, which is an STA tool. That's
Can you implement all the projects using Verilog?
Yeah, yes. The test bench can be further improved using system Verilog, but even using Verilog, all of it can be implemented, especially the design can be perfectly implemented. And even the test benches also can be implemented using Verilog.
How confident have you become?
Very much so. Actually, just day before yesterday, we have a test where we wrote every single code and data path and control path of all the projects we have done. We are sat there for around 3 hours. And I'm so much confident that I can say, even checking every single syntax, I haven't made a single error. And some may have made some errors, but still we were very confident to do so. Especially in the logic part. Some may still lightly struggle with the syntax part, but no one is in any way missing any logical.